Okay, good morning and welcome back. So let's see where we're at here. Syllabus. Okay, so you should have saw your midterm grades. So double check those. The midterm grades are posted on Blackboard, and I emailed you my solutions to the exam. So the scores were pretty high. So I don't think there'll be any questions, but let me know if you have any questions about your midterm. Midterm 1, all right, so we're starting the second third of the class. The two assignments that I emailed yesterday that were due today, that most of you already turned in, are example 4.4. No, sorry. The curve fitting assignment, right? And also example 4.5. So those are the two we did the week before spring break, and those are due today. And so we're still, I guess, one day behind because of the President's Day skip, but we're almost caught up. We'll be caught up by the second midterm, I think. So what we're going to do today is the assignment drug production, and then on Wednesday we'll do example 4.8. So we're kind of again 1 week behind, but we're getting caught up here. So today's assignment is the assignment drug production. Okay. All right. So again, this one and this one due today, and we'll do this one in class today. It's due next Monday. All right, so if you go to the assignment drug production section, there's just one Word document with the assignment. You can open that up. Okay, so there's basically, it's a little bit different. It's basically a bunch of problems that are associated with the last assignment we did, the REPCO one, example 4.5, I think. And so we did a practice problem right before spring break, but this one will give us more practice on this type of exam question that's going to be coming up in a few weeks, or more than a few weeks. But there's no Excel file here. It's kind of just there's 5 questions, all based on examples from that drug production Excel file, and we'll kind of go through these. So we'll do a bunch of these. There's 5 total. We'll go through a majority of them in class, and I'll have you do at least one on your own. But these 5 questions are the assignment for today, and so we'll start going through this. And so make sure if you have any questions as we're going along, that you ask them, because I want to make sure you understand the logic and how we get these problems done. So they're a little tricky, but they're kind of fun. And again, this assignment is based on the drug production, the example 4.5 assignment. So this is answering these 5 questions is what's due for this assignment. All right, and so you're just going to post your Word file or PDF into the Blackboard forum. Yeah. So no Excel file due for this one, but you're going to have to post your answer sheet, which is probably going to be in Word form, or if you want to do it on hand, you could do a PDF. But your answer sheet just goes in the same place. Okay, right there after example 4.5. All right, so let's do. So they get progressively slightly harder, I guess. But the logic or the recipe is the same. All right, so you have a screen cap that's modified based on example 4.5, and you got some questions to go with it. And so I think this is an important type of question because when you simplify to only one type of input to your production process, then this shows you exactly how you can find what the best thing to do with your resources is. Okay, so number one. All right, so if you did example 4.5, we've got 3 different types of drugs we're choosing from. They each have their own selling price. We have to figure out how much labor hours go into each. And usually, or always, drug A is a little bit cheaper, drug B is a little more expensive, and drug C is the most expensive because it's the most labor intensive. Okay, so part A. Assuming no changes, which drug is sold exclusively and what explains these results? So if you look, you'll see that this first part's easy. You just have to look at units sold, and you can see drug A, 0, drug B, 0, drug C, 1333. So clearly, we're not selling any drug A, any drug B, only drug C. All right, and what explains these results? So remember I told you because there's only one input, which is labor, then the money you get by selling the item is only as good as the labor that goes into it. So the term or the identity that determines this is revenue per labor hour. Okay, so whichever one is being sold initially, that's got to be the one that has the highest revenue per labor hour. And so let's calculate. Or let's first write the general formula for revenue per labor hour, and then we'll figure out what the revenue per labor hour is for drug C, and then we'll answer the rest of the problem. So revenue per labor hour is the revenue per labor hour that goes into each drug. So it's essentially the selling price of the drug so it's the drug selling price divided by the labor hours required. So when you sell it on the market, you get that revenue, and there's no profit calculation here. It's just revenue per labor hour. So what you get selling it divided by how much labor that goes into it determines how profitable that drug is. So let's do this calculation for drug A, or sorry, drug C. Okay, so the revenue, oops. So the revenue per labor hour for drug C is the selling price of drug C, which is, just look here, unit selling price, 3,000. Okay, and the labor hours required, we have to figure that out. So you kind of got to work backwards, where if you look at, it takes 1 hour to make drug A, and then you need one drug A to make one drug B, and then 1 more hour, so 1 plus 1 for drug B, and then for drug C you need 1 drug B, and then 1 more hour. So it's 2 plus 1 here. So if you start with drug A, it's just 1. If you do drug B, it's 1 plus 1, which is 2. And then drug C, it's 2 plus 1, which is 3 hours. Okay, so it takes 3 hours to make one drug C. Okay, so that means that 3,000 in revenue divided by 3 hours gives us 1,000 per hour. Okay, so the revenue per labor hour for each drug C is 1,000 per hour. So that means that every labor hour that goes into producing drug C gives us a revenue of 1,000. All right, so drug C's revenue per labor hour is 1,000. So that means that that's the benchmark that we have to compare the other drugs to. So it must be that the other drugs are giving less than $1,000 per labor hour. Otherwise, they'd be sold instead. So yeah. Okay, so the first step for these problems is um, calculate the revenue, or find out which drug is being sold, calculate the revenue per labor hour for that drug, and then we'll use that to compare the other ones. Okay, so B, drug A's price needs to be greater than or equal to what for only A to be sold? So we're trying to see for drug A to be at least comparable, it has to come out to $1,000 per labor hour. Okay, so let's first calculate the current revenue per labor hour for drug C and or drug A and see that it's not comparable. All right, so drug A's selling price is, look here, 900. Okay, and it only takes just there's no other prior ingredients. It just takes the 1 hour. Okay, but if you do the conversion, that's only $900 per hour. So that's less profitable than drug C, right? Okay, so all we have to do is figure out what the price has to rise to in the market for drug A to be comparable, to be equivalent to $1,000 per hour, right? Okay, so we're trying to figure out the price divided by 1 that equals 1,000. Now you probably know what that is, but I'll just do the process. Okay, so we're trying to figure out what price divided by 1 hour gives us $1,000 per hour. And this one's pretty simple, but you can see that 1,000 divided by 1 would give us exactly $1,000 per hour. So for drug A, it's got to be $1,000 for the drug for it to be comparable at the same revenue per labor hour for drug C. Okay, so the answer here is A's price needs to be greater than or equal to 1,000. All right, so now we'll do the comparison for drug B. but it's the same idea. All right, so B's price needs to be greater than or equal to what for only B to be sold? So first, let's figure out the uh, insufficient revenue per labor hour for drug B at the current situation. Okay, so what is B's selling price? It is 1,000. And how many hours does it take to make drug B? You can see you need, so the drugs B and C, they need some of the ingredients of the prior drug because they're a little more complicated. So it'll tell you what it needs, and you got to factor in the labor hours to make that input. So drug A is an input to drug B. So it takes 1 hour to make a drug A, and then 1 additional hour here to convert it into drug B. So it's 1 plus 1, which is 2. All right, so that right now, without any changes, drug B is only giving us $500 per hour. Okay, and we need to figure out the price that has to go to. You probably know what that is. That has to be comparable and make them all comparable to $1,000 per hour. Okay, so what's this price? So you can see that what divided by 2 equals 1,000, and that's obviously 2,000. Okay, so you can kind of see what we've done here is currently, without any changes, you can see that the most profitable drug in terms of revenue per labor hour was drug C. And we tried to figure out if something happened to the demand or the market for these other drugs, what's the tipping point at which those would be comparable or better. So basically, if drug C's price is 3,000, drug A's price is 1,000, and drug B's price is 2,000, they all give exactly the same revenue per labor hour of $1,000 per hour. Okay, if there's any changes, then you got to figure out the changes. But that's the break-even point, given the labor hours that go into making each of these drugs. Okay, so we've got 4 more of these. But do we see the idea? Questions on kind of the process or anything here? Everyone sees what the idea is.
Yeah, I'm following you.
Yeah.
Okay. All right. So you'll see that probably the most difficult thing is once the hours start adding up is figuring out the exact labor hours that go into each drug, but the rest of it's pretty much the same. So just stick with the same process, and I'd say double check your math because I try to make it. I think all of them come out like no decimals, and so if you get something with decimals, it's probably wrong. So that's a good way to check. All right. Okay, number 2. So same process, but the hours start getting more complicated. So, but stick with the recipe. So let's see. Number 2. All right. So the things all this other stuff you don't have to worry about. All for this problem or for this point, just look at the labor hours and the ingredients and the selling prices. So all the stuff in blue is what you're looking at, and I guess units sold too. Okay. So A. For number 2, assuming no changes, which drug is sold exclusively and what explains these results? So in this case, you'll see that it's again drug C. So no drug A's, no drug B's, only drug C. Okay, so drug C, and the thing that explains that is always going to be revenue per labor hour. And let's calculate the revenue per labor hour for drug C, right, and see what that is. Okay, so the selling price of drug C is 6,000. All right, and now we got to figure out the labor hours that go into it. So let's see. We're going to start with drug A. So it takes 2 to make drug A. Well, so let's. I'm going to see if someone can figure out the answer here. So, can someone figure out how many labor hours it takes to make one drug C and post it? How many?
6.
6? Yeah, 6 is correct. So let me show you. So it's 2 for drug A. And so each of those 1 drug A's that go into drug B are an hour. So that's 2 plus 2, which is 4. And you need 1 drug B to make drug C. So it takes 4 hours to make that 1 drug B, and then 2 more hours to make it drug C. So that's correct. So you got to start here. So 2 hours to make a drug A, 4 hours to make a drug B, and then 6 hours to make a drug C. Right? 4 plus 2. And so remember, always get the labor hours for the input, and then add the additional hours to make it into that drug. So 6 hours here. And so you can see that works out nicely to give us the same, $1,000 per labor hour. Okay, so it must be that drug A and drug B are giving us less than a return of $1,000 per hour. But let's figure out what the breaking point is for those to be just as comparable. All right, so let's do B. A's price needs to be what for it to be sold? First, figure out what the current revenue per labor hour is, and then figure out the increase that would make it equivalent to drug C. Okay, so drug A's price is now currently 1,000. And it takes 2 hours to make it, right? Okay, and that only gives us $500 per hour, which is clearly less than the 1,000 for drug C. Okay, so what does A's price have to be? What divided by 2 gives us 1,000, and obviously that is 2,000. What just happened? All right, so I somehow just hit the print shortcut on accident. Okay, so A's price needs to be greater than or equal to 2,000. Okay. All right, for drug C, sorry, for drug B, let's do the same analysis. Okay, so we'll first get the revenue per labor hour for currently for drugs B. Okay, and that is its price, which is 3,000. Okay, and it takes one drug A, which takes 2 hours, and then 2 more hours to make a drug B. So 2 plus 2 is 4. 4 hours to make a drug B. All right, and that is I don't know, less than 1,000. What's 3,000 divided by 4?
75 or 750.
750. Thank you. All right, so that's less than $1,000 per hour. So let's figure out the price, and we can see what that's going to be. That's going to give us 1,000. Looks like it's going to be 4, but let me set up the thing. So we're trying to figure out the price divided by 4 that would give us 1,000 per hour, which is going to be 4,000. All right, so what divided by 4 is 1,000, and that is 4,000. Okay, so that's number 2. So what we determined is that if The price of drug C is 6,000. The price of drug A is 2,000, and the price of drug B is 4,000. They all give us exactly $1,000 per labor hour. If anything changes, then you got to figure out the result. Okay, so 2,000 for drug A, 4,000 for drug B. Okay, so we got some more. Everyone good so far on what we're doing? All right. Okay, let's do number 3, yeah? All right, so this one's, the hours are starting to add up, and it's not always going to be $1,000 per hour. I think this one's a little bit different, but let's see. So number 3, assuming no changes, which drug is sold exclusively, and what explains these results? So what is the drug here? Drug A. So we're not selling drug C or drug B, only drug A. So drug A is the answer to part A for this one. Okay, so drug A, because it must have the highest revenue per labor hour. And what is that revenue per labor hour? Let's figure that out. Okay, drug A's price is $2, and it takes 2 hours to make a drug A. So 2 divided by 2. All right, so this drug is a lot less profitable than the previous ones, but $1 per hour is what drug A is currently giving us. So 2 divided by 2 gives us a revenue per labor hour of $1 per hour. So this is the comparison benchmark. All right. Okay, so what about B? Okay, how much is drug B selling for? $8.
Welcome to the club, man. Welcome to the club.
No. I've never seen it.
Welcome to the fucking club, Tanner, of no one noticing what you say until they realize, oh my god, dude. Dude.
The young Garrett looks like that.
I had to mute somebody because we got some I don't know what we got. Okay. What happened here? So we got, all right, so the revenue per labor hour is, we're going to figure that out. Okay, so drug B is selling for $8. All right, so can someone figure out how many hours it takes to make one drug B?
10?
Almost.
Or is it 12? It's 12.
It's 12, yeah. So because
Yeah, my fault.
each of these drug A's is 2, right? So it's 2 plus 2, which is 4, then 4 plus 8 is 12. Yeah. So it's, right? So you gotta, it's only because this one took 2. So each of these drug A's takes 2 hours, so that's 4. And then 4 plus 8 is 12. Yeah. All right. 8 divided by 12 is not $1 per hour. It's less than that. It's I don't know, 4. What's 8 divided by 12? 2/3, which is about 66 cents.
Yeah.
Yeah. So less than $1 per hour. Okay, so we know what's gonna be here, but we're trying to figure out the price. If you divide that by the 12 hours to make it, that gives us $1 per hour. All right. Okay, and what divided by 12 is 12? That's 12. Okay, so B's price needs to be greater than or equal to 12 for it to be giving us $1 per hour. Yeah. All right, now let's do drug C. Okay, drug C is selling at $11. This math is not going to come out nice, but $11. Okay, now who can tell me how many hours it takes to make one drug C?
Is it 18?
It is. Let's see. Close.
6,
It's close.
8,
It's close to 18.
16?
Other way, other direction.
Oh, shoot. So then it would be 20.
Yeah. So see how it's
I'm messing up.
well. Let's see. The one drug B right here takes 12 hours. All right, and then each of these drug A's takes 2 hours, so that's 3 times 2, which is 6. So 12 plus 6 is 18, plus 2 more is 20, right?
Okay.
Yeah, so maybe I should, this one's getting, let me see if I can do the full, so, all right, so if you can break it down by just each drug, then it can simplify it. So okay, so if you start with just drug A, you need 3 drug A's, all right? Okay, so you need 3 A's, and those each take 2 hours. All right, and how many drug B's you need? 1. And we determined before that drug B takes 12 hours. Okay, and then just add in like the factory hours to make it drug C, which are 2. Okay, so that gives us 6 plus 12 plus 2. All right, which is 20. There we go. Not a good highlight color. There we go. Okay, so if you do the full breakdown, it might uncomplicate things, but it takes I believe 20 hours. I'm sorry, to make a drug C. 6 plus 2 plus 2, which is 20. All right, so that is something less than $1. 11 divided by 20 is a little more than 50 cents. I don't know exactly, but we'll just say 55 cents. All right, and what divided by 20 is going to give us 1, and we know what that is, but okay, so what divided by 20 is 1, that's 20. Okay, so we've determined for number 3, given the labor hours, which take the most effort to figure out, that if drug A is $2, drug B is $12, and drug C is $20, they're all going to give us $1 per hour, revenue per labor hour, and if anything changes, you got to figure out the change, like we did there. So that's that one. Okay. All right. So everyone good on this? So maybe there's 5 of them. Maybe we'll do one more here, and then you can do number 5 is a take home part. So you got to turn in all of them, but we'll do most of them together in class. All right. So we've already done 3. There's 2 more. Okay, so let's do number 4. Same thing, same type of question, I guess. All right, so A's assuming no changes, which drug is sold exclusively and what explains these results? So this time it's drug A again, right? No drug C's, no drug B's, just drug A. Okay, so it's drug A, and revenue per labor hour explains that. And what is the revenue per labor hour? Let's calculate that for drug A. All right. Drug A's price is 30. And it takes 3 hours to make a drug A. Yeah. So okay. So that means that the revenue per labor hour that drug A is giving us is $10 per hour, which must mean that the other two drugs are giving us less. Let's figure out what those other two drugs are giving us, and then let's figure out the price those need to rise to be equivalent to drug A and give us $10 per hour. Okay, let's calculate the revenue per labor hour for drug B. Okay, drug B's price is 50. All right, and all right. So how many hours does it take to make one drug B? Can we figure that out?
Six.
Yeah, 6. So this one just the 3 hours to make the one drug A, plus the 3. 3 plus 3 is 6. Yeah, 6 hours. All right, which is going to give us less than $10 per hour. I don't know exactly, but it's just like 50 divided by 6 is like 850 or something. I don't
Yeah, it's 833.
know. Okay, thanks. Okay, and let's obviously figure out the price this needs to go to divided by 6. That gives us 10. We can see what's coming here, but B's price. Okay, so what divided by 6 is 10? That's 60. So 60. Okay, so B's price needs to be greater than or equal to 60 for it to be $10 per hour or more. So let's do the final part for drug C. Okay, so let's find the current revenue per labor hour for drug C. drug C's price is 100. All right. Now, can someone figure out how many hours it takes to make one drug C?
Would be 15.
Let's see. So B is 6 plus 9. No, a little more than 15.
I got 18.
Yeah, 18 is it. So I'll do the calculation, but it's the one drug B is 6. The 3 drug A's, 3 times 3 is 9. And then 6 plus 9 is 15 plus 3 is 18. Yeah, so I think it's 18. And let me write out the full equation. Okay, so if you do for drug C, the labor hours to make a drug C, the general formula is the hours that go from A plus the hours from B plus the hours to make it C. All right, and so we need 3 drug A's, and each of those drug A's takes 3 hours, so 3 times 3. We need 1 drug B, and we determined from part B that each drug B takes 6 hours, right? And then the additional hours to make it drug C are 3. So that gives us 9 plus 6 plus 3. All right, so yeah, 18 hours. All right, so that's 100 divided by 18 is less than 10. Exactly what this is. Maybe 100 divided by 20 would be 5, so it's like 4.5 or something. Okay, so let's figure out the price that if you divide it by 18, you get exactly $10 per hour. So okay, so what divided by 18 is 10. That's C's price would have to be 180, right? Okay, so for number 4, if drug A is $10, if drug A is $30, drug B is 60, and drug C is 180, they all give us $10 per labor hour, and we figured that out. So yeah, all right. So should we just? Do you want to just do the last one? I wasn't gonna make you do number 5 for for homework, but I guess we have extra time, so we can.
Yeah.
All right, let's just. Okay. All right. Good questions so far? Did everyone following along? And because there'll be a big one like this on the take-home exam, so make sure that all this makes sense and make sure you can figure out the hours. I think this one is the most complicated in terms of the hours, but let's do it. Okay. Okay, assuming no changes, which drug is sold exclusively here? Now we finally get drug B. All right, so this is the no drug C's, no drug A's, drug B.
I have a question.
Yeah,
How do we produce no drug Bs but sold 250 of them?
wait, okay, so why do we, oh, well, we produced 250, right?
Oh, my bad. Never mind. Sorry.
Yeah, that's okay. Yeah, it's because all the drug, so all the drug A's went into drug B's and nothing happened to drug C. Yeah, so all these went to drug B and then all the drug B's were sold, right? God, I got a new keyboard and the print screen button is right by the backspace and I keep hitting it. Okay, what's the revenue per labor hour for drug B? All right, 160 is the price for drug B. All right. Okay, so how many hours does it take to make one drug B?
16.
Yeah. One drug A, which is 8. 8 plus 8 is 16. Yeah. Which means we're getting we're getting $10 per labor hour, yeah? All right. Okay, what about drug A? Let's see what that has to go to be comparable. Let's first get the revenue per labor hours that are currently happening for drug A. Okay, drug A's price is 75. It takes 8 hours to make it. Which means we're getting, I don't know, something less than $10 per hour. So 75 divided by 8 is not 10, it's less than 10.
It's 9.375.
Okay, thank you. Okay, so let's find the price that if you divide it by 8, it gives us 10. We probably know what that is, but okay, so what divided by 8 is 10? That's if A's price goes to 80, right? 80 divided by 10 is 80 divided by 8 is 10. Okay, all right, let's finish this up with drug C. All right, so drug C is going to take some hours to make. We'll have to figure those out in a minute. All right, so what's the revenue per labor hour for drug C? It sells at 300. All right, so anyone want to take a guess at the hours for drug C?
Is it 24 hours?
I got 32.
I got 32 as well.
Oh yeah, I'm 32. My bad.
Okay, well, it sounds like it's. I think it's 32, but I'll do the little calculation. But yeah, I think it's 32. Okay, so if we break it down, we see that we need one drug A, and it takes 8 hours to make a drug A. We need one drug B, and it takes 16 hours to make a drug B. Then we're going to add 8 more hours to make the drug C, right? So that gives us 8. Okay, so 8 plus 16 plus 8, which is, 32. So 8 plus 8 is 16. 16 plus 16 is 32. Okay, so you can, if you can do it in your head, that's great. But if you want to double check, just writing it out, you'll have plenty of time to do these. So no rewards for doing it faster. So maybe just double check if there's a lot of hours that they come out correctly. And so 300 divided by 32. Okay, definitely less than $10 per hour. It's like 9 something. Okay, so we need to figure out C's price. If you divide it by 32 hours to make it, that gives us $10 per hour. So that's going to be 320, right? So what divided by 32, or 32 times 10, is 320. Okay, so C's price needs to be greater than or equal to 320. So we've determined that to give us $10 per hour, all equivalent is A's or B's price is 160, A's price is 80, and C's price is 320. So see, all the math on all these worked out with no decimals, I think, and so that's kind of a way to double check. Okay, so questions on this assignment that we just completed? All right, so make sure that you understand how to do these, and I know we did them all together, but maybe try to make sure you can do them on your own. Don't look at the answers and see if you can figure them out, but this assignment is done. Okay, so that we just did goes here. Okay, so go ahead and post your answer sheet to the drug production one right here by next Monday. And so there's no Excel file, just if you did it on a Word document, you can post that, or if you did it on a piece of paper, just either make it a PDF or post a photo of your piece of paper. Okay, and all right, so we're just about done here. Just a reminder that this one's due today. If you haven't posted that, post that. This one's due today. Okay, and then this one that we just finished is due next Monday, and we'll do this one on Wednesday, which is also due next Monday. All right, so that's where we're at. And the grades for all your other assignments and your exams should be viewable now on Blackboard. Okay, I think that's it for this morning, and thanks everyone for coming. I'll see you all Wednesday morning, same time, and have a good week.
Thank you, Secretary.
Professor. You.
Thanks.
Professor, I have a question.
Yeah.
This was the right time for me to hop back in and start doing everything, correct?
Yeah, this is Cole.
Yeah.
Yeah, so right after the mid, right, so exactly. Let me see what, I think, let me see which one. I think you need to turn in, you've turned in everything up to example 4.4.
Yeah.
And so I think you need to turn in this one. You haven't done example 4 or 5, right?
I would have to go back in and check.
Yeah, I don't, actually, do you want me to check right now?
Yeah, if you could, that'd be great.
All right, don't look at everybody else's grade, but it doesn't matter. Let's see. Yeah, so I think after last spring break, example 4.5 was the first one that we did coming back. So yeah, the one you need to start with is example 4.5.
Okay, I'll do that and then catch up.
Yeah, you don't. It's due today, but you can turn it in next Monday because I don't think you didn't know about it.
Yeah, thank you.
Andy, the video for that one's up. I don't know if you came last. When was that? The Wednesday before spring break?
I think I came, but I didn't do it just because I thought I wasn't having to do it.
Oh yeah. I think we're maybe one ahead of what that class was, but yeah. So everything from this one on, I think you need to do.
Okay, sounds good.
Okay. So example 4.5, and then the one we just did. Yeah.
Yeah. And just wondering, since everything's posted, we could go ahead a little bit, correct? Or do you want to wait until we do it in class?
No, you're welcome to go ahead if you want to. Yeah. Do you have the textbook?
I think I have. Yeah, I have it because they sent me all the extra textbooks.
Okay. Yeah. You'll probably need the tech if you want to go ahead. You'll probably need the textbook to see some of the pictures and formulas. But if you have the textbook, you can go ahead and do it.
Okay.
Do it at your own pace. Yeah.
Awesome. Thank you so much.
All right.
Have a great rest of your day. See you Wednesday.
Okay. Thanks.